Most analytics begin as an isolated desktop spreadsheet, a single point of data. But to drive an entire enterprise, that localized data must expand into a sprawling, interconnected network. Power BI, operating as a core component of the Microsoft Fabric ecosystem, functions as a high-volume data modeling and analytics engine. It achieves scale through a bifurcated architecture. It splits the workload between a strictly controlled local authoring environment and a distributed cloud service. Understanding this system requires tracing the data. We will track the journey from the initial local installation up through the web front-end clusters, through the multi-hop tenant routing protocol, and finally into the secure enterprise backend. Mastering this specific architectural split is the only way to scale a localized data model into a globally secure enterprise platform. The foundation of this system begins locally with a free Windows application called Power BI Desktop. This is the isolated environment where report creators build their initial logic. Creators first ingest raw data using the Power Query interface, establishing initial connections to external sources and cleaning the incoming records. Once loaded, developers build the relational model and compute data analysis expressions, or DAX. At this stage, Power BI relies on the VertiPack engine, an in-memory columnar database that compresses raw tables into a highly optimized local cache. Developers can extend the standard reporting library beyond the default charts by utilizing the Power BI Client SDK and REST APIs to build custom visual elements. However, all custom visual code operates inside a strict sandbox. This explicitly prevents errant or malicious code from executing unauthorized data transmissions outside the local environment. Because local compute has direct access to the raw underlying data, strict local sandboxing is required before any model can safely transition to the network. When the local model is complete, the creator publishes it, pushing the structure into the Azure-backed software-as-a-service platform known as the Power BI service. This cloud service operates across two distinct tiers. The first is the Web Front-End, or WFE, cluster. The WFE cluster does not hold your data. Instead, it interacts with the Azure Content Delivery Network to rapidly serve the static files required to load the interface in the user's browser. The actual data resides in the second tier, the backend clusters. This is the stateful engine housing the Azure SQL databases and microservices that process complex queries. Notice steps 4, 5, and 13. Datasets are decoupled from reports, residing centrally in workspaces. Once centralized, they become discoverable via the datasets hub. Secondary users don't rebuild data. They connect directly to existing models via live connections, building reports on a shared foundation. Separating the front-end file delivery of the WFE from the back-end state of the workspace datasets provides the foundation for Power BI's massive horizontal scalability. In a massive multi-tenant cloud environment, the system faces an immediate architectural challenge: how to route a user to their specific data without exposing the data of other tenants. The routing sequence begins when a user requests access. Azure Traffic Manager intercepts the DNS query to determine the nearest geographical WFE node. The WFE node rejects direct access to the backend. Instead, it redirects the unauthenticated user to Microsoft Entra IB. The user authenticates against the directory and receives a secure access token in return. Armed with this token, the user's browser queries the Power BI Global Service Registry. The global service reads the token and identifies the user's specific tenant ID. Using that exact ID, the global service retrieves and outputs the URL of the user's assigned home backend cluster. Finally, the browser takes that URL and establishes a direct connection to the authorized backend API, bypassing the registry for all subsequent requests. This strict multi-hop routing sequence guarantees absolute tenant isolation in a shared cloud environment. As an enterprise scales its self-service capabilities and introduces advanced AI tools, protecting this architecture requires a strict governance overlay. The first layer consists of network precautions. Administrators utilize service tags to define network access controls and deploy virtual network gateways to securely bridge the cloud service to on-premises data sources. The second layer involves data precautions. The system integrates Microsoft Purview data loss prevention policies, allowing admins to apply sensitivity labels directly to specific datasets. Crucially, these sensitivity labels persist. If a user exports highly confidential data to an Excel or PDF file, the security restrictions travel with the document. This governance framework is an absolute requirement when introducing extensibility features, such as using Copilot AI to generate narrative summaries or write complex DAX formulas. Running AI models require Fabric-enabled premium capacities. This compute infrastructure ensures that while the AI processes data, it never leaves the governed tenant boundary. Without virtual networks and Purview integration, external extensibility is a severe liability. With them, AI becomes a safe, heavily governed enterprise asset. The complete architectural pipeline travels from the compressed local VertiPack engine through the Entra ID routing protocol and terminates in the isolated backend cluster. This design dictates Power BI's ideal use case. It is built for organizations requiring massive scalability that are already deeply embedded in the Microsoft Azure infrastructure. Compare this to the wider market. Platforms like Looker rely heavily on centralized code-based LookML modeling, while Tableau prioritizes unconstrained front-end visualization flexibility. Power BI's competitive advantage lies in its deep integration of enterprise data governance, paired with highly cost-effective Azure compute capabilities. By architecting a strict boundary between WFE delivery and back-end state, system administrators can deploy massive self-service analytics and AI without compromising data integrity.